Alright, in this lesson you're going to be introduced to something called a log function. And the idea of a log function is it sounds a lot more complicated than it is. So we're going to spend this first lesson in logs going over what a log means, but the questions you will have to do are actually very simple. Okay, so bear with me as we go through this, but not everything that we do here will be necessary for you to learn. In fact, I was tempted to kind of skip this lesson over totally, but then I thought I should at least introduce logs to you just so you've heard it before, so if you ever do see it in the future, you kind of have an idea of what it is. Okay, so you're going to have to use decimals here just for the introduction. We won't use it in class or on tests, but it'll help us to see some of the things that you're supposed to learn here. So we've talked about what an exponential function is. Okay, and an exponential function, we saw in the previous couple of lessons that they either go like this or like this. They always have that y-intercept of 1. So let's look at an example here. The exponential function of y equals 2 to the x. Okay, so a couple of values here. 2 cubed is 8, 2 squared is 4, 2 to the power 1. So we're just going to do these really quickly. So based on those answers, what are some points that lie on the graph y equals 2 to the power x? Well, one point would be if x is 3, y is 8. If x is 2, y is 4. If x is 1, y is 2. If x is 0, y is 1. And by the way, that's at 0, right? We have 0, 1 in that graph. If x is negative 1, then y is a half. If x is negative 2, y is a quarter. And if x is negative 3, y is 1/8. Okay, so that's just using the equation y equals 2 to the power x. If we put in those values of x, what are we going to get out? Okay, the inverse function reverses x and y values. Okay, so what points must lie on the inverse? So if we reverse the x and y values, you would get these points. So we're just switching the x and y values for each one. This is the inverse of that function, y equals 2 to the power x. And in fact, these are the points on a log graph, on the logarithmic graph. Okay, the log function is the inverse of an exponential function. Okay, now this looks kind of crazy here. Y equals a log base b of x. A couple parameters here. B has to be greater than 0 and it can't be 1. Okay, we don't really need to worry too much about that because you're not going to get equations where they're not that. Okay, so visit the decimals link above and turn on y equals a log b of x by clicking the circle. So you can check out that link up top and follow it there, but that link is not active if you're in OneNote. So what I'm going to do is type this in. Okay, so I'm just going to go to decimals here, and what I did is I typed in a log base b of x. So in case you're not sure where all of that is, if you want letters, you would press this. Okay, and you can see all the letters there. All right, and if I want the function, the log function, I'm going to go here under miscellaneous. Oh, quit popping up like that. Okay, so you can see under miscellaneous I have log base a. Okay, and I just happen to put in base b. So don't worry even if you don't need to type this in, because you don't need to know how to do this. I just want you to look at this graph. Okay, so I'm going to just delete that graph for a second. So this is the log graph. Okay, a couple of things you should notice. Here is the X-Intercept. It happens to be at 1. And if you were to follow this line, we actually have an asymptote here that we're at 0, because this log graph will never ever touch x equals 0. It's going to get closer and closer, and it looks like it's touching down there, but it actually isn't. Okay, and if you know that the base in this case is 2, if we increase the base, look at how the graph changes, but notice that the x-intercept never changes. Okay, so this graph looks all different. The bigger the number it gets, the steeper it gets here. Okay, and we can go all the way to 10. That's log base 10. All right. Now, I remember I told you that the log is the inverse of the exponential graph. So take a look at this graph. This is the graph y equals 10 to the power of x. You can see that the y-intercept is 1. This is the graph we've been working on already. Y equals 10 to the power x. And it is exactly the inverse of the log graph. How can you tell if it's the inverse? Well, let me show you something. If you go y equals x, you see how that line kind of divides the two graphs? In fact, if you think of that line as a mirror, these two graphs will be exactly reflected over that line y equals x. Okay, and that's how you tell if they're an inverse. So let's go back to our notes. All right, the log function with base 10, here is the log function base 10. By the way, we don't have to put the 10 in. If you don't see anything, we're assuming that it's base 10, and that's all you'll be responsible for this year. You don't have to worry about other bases. We're going to deal with base 10 and one other one I'll talk about in a minute. Okay, so that's the log function. Okay, the expression a log 10, that's base 10 of x, is known as the common log, or the log with base 10, and we often don't write that 10 in there. Okay, now here's what I would like you also to know, that the function log base 10 of x is the same as this. These are the same things. Now that looks a little confusing. How are they the same? Well, anytime I see a log, alright, let me just write it over here. Y equals, let's just say this is what you see. Alright, because you don't see the 10, this means 10. When I see this, I think 10 to what power is x? Alright, these two mean the same thing, and that's how sometimes it helps to understand them. So for example, if you had this, log base 10 of x equals, let's say 3. What does this mean? What is the value of x here? Well, this means 10 to the power of 3 is x. So in this case, x would be 1,000. Okay, that's how you read a log. Whenever I see the base, I go base to what power is x. Okay. So, a couple of examples here. Let's take a look at log base 10 compared to this. These are inverses of each other. What is the x-intercept of y equals log base 10? Well, let's go look at, let's change the base to 10. I've done that. I'm going to get rid of the line y equals x, and let's get rid of the exponent. Let's just look at the log graph. Okay, so we have the x-intercept, and we actually don't have a y-intercept. So the x-intercept is 1, the y-intercept, there is none. What is the end behavior? Well, it's rising to quadrant 1, or we've also written that as it's going from quadrant 4 to quadrant 1. Okay, what's the domain? Well, this is interesting. If I know that I can't get to 0 here, I'm going to go up to 0, or almost to 0, not quite. So from 0 to infinity. And the range is negative infinity to infinity. Now let's do the exponential graph. So now I'm going to hide that one, and I'm going to do this one. So this one has a y-intercept, but doesn't have an x-intercept. Okay. What is the end behavior? This is from quadrant 2 to quadrant 1. And the domain and range are exactly the opposite of the log. If you notice these are exactly switched. Okay, so is this. They're exactly switched. They're the inverses. The x and the y values are switching between these two graphs. Okay, now I know this is a lot of information to get all at one lesson. Don't worry about that. The reality is pre-cal takes like 2 weeks to do this. You guys are getting it in one lesson. The good news is you don't have to know the details too much, and you'll see what I mean by that when I get to the questions we're going to do. Okay, so it says find the x-intercept. Yeah, we did that. Now turn on the graph y equals. This is called the line of reflection. You saw that. You saw how these two graphs are reflected right on that line. Okay, use the graph and the filled out table. What can you conclude about the relationship between y equals log base 10 and y equals 10 to the power x? These are inverses, which means the x and y values have switched. Okay, now there's one other thing I wanted to go before we get into some questions. I just wanted to go over this. The natural log. So we just talked about the common log. That was base 10. The natural log is base e. Okay, and if you see this, that just means the same thing as this. So instead of log base e, we write ln. That's the natural log. Okay, so quick review. We've learned base 10 and we've learned base e. Base e, instead of writing that, we write lnx. Okay, so let's compare these two graphs. So what is the x-intercept for base e? Well, let's go and do this first. We're more familiar with the exponential function. You know that the exponential function goes like this if our base is bigger than 1. So we're going to say there is no x-intercept, but the y-intercept is 1. Now, knowing these are inverses of each other, that means the x-intercept here will be 1, but the y-intercept will have none. Okay, end behavior, quadrant 2 to quadrant 1. Here it's 4 to 1. What is the domain for the exponential? We know this is negative infinity to infinity. So then this is negative infinity to infinity, the range here. I know that the range in the exponential is 0 to infinity. So then that must mean the domain here is 0 to infinity. Okay, these are again inverses. And again, I also know that this is lots of information. Don't worry about that. Let's summarize this and then try some questions. The inverse of an exponential function with base b. So here is the exponential function we've talked about so much already. The inverse is called the log function, and it is written like this. Okay? If a point lies on the graph of the exponential, then the corresponding point when we switch x and y lies on the log graph. Okay, so let's try a few questions here. Sketch the graph. So now I want to use our calculator. Okay, so let's go to our calculator. Let's clear everything off here. We're going to go to y equals. We'll clear this. We'll get rid of our scatter plot. Whoops. Okay, clear. Yeah, so here we have this. So what do we want to put on there? we want to do log base 10 and y equals 10 to the power x. We want to put both of those on. So let's go log. Now the nice thing about your calculator is that log button is base 10. Okay, it's always base 10. Don't have to worry about changing that. Okay, and then we're going to go 10 to the power of x. So those are the two graphs we want to look at. Let's go zoom 6. Okay, there are the two graphs. Now it doesn't look very nice and you can't zoom in like Desmos, but we can find the x and y intercepts of both of those. Okay, so let's first of all sketch it. Now when on your graph you just kind of see this and you see this. There's a couple things about that. First of all, we know the exponential function goes like this. We can draw this knowing that it looks like that. So the log function is going to be like this. And remember, it's supposed to look like it reflects over that line. Okay? And it says be sure to label the intercepts. Well, we should label the two intercepts like that. Okay, let's try the next one. Sketch the graphs y equals ln x and y equals ex. So we'll go to here, here. Let's clear these two. And here's ln x. Okay, and then e to the power of x, well, you actually have that button. If you go second ln, it goes e to the power of, and we want to put x. All right, zoom 6 again. Now, it looks almost identical. Okay, and for our purposes, it's not going to be much different. We're going to draw the same graph here. Okay, this is still 1, this is still 1. Okay. Though those graphs look the same, there are differences. So let's quickly just take a look at some differences. Well, we'll answer some questions first. Set A and B as needed to graph y equals log. Okay, so we've done that. Turn graphs on and off as necessary. Okay, we've done that. Draw a label sketch. Okay, how are the graphs the same? They look identical. X-intercept's the same. Y-intercept's the same. How are the graphs different? Well, this is a little trickier because they don't look different when we've sketched it there. So let's go back to here, and I'm going to delete this one. I'm going to clear that one, and I'm going to graph log x. I want to see which one's which. Okay, now I won't be able to see this unless I change this a little bit. Let's press enter again, and you can see my line just became darker. Okay, so now I'm going to go zoom 6. Let's see if I can see how they're different. Alright, looks kind of ugly. Okay, but I see this graph and this graph. They both have an x-intercept of 1. Which one is which? Okay, this one was y equals ln x. This one was y equals log x. So what made one turn faster? Well, don't forget, here our base is e, here our base is 10. E is about 2.7. So the bigger the number, sort of the steeper this thing will turn. Okay, so how are they different? I don't know how you want to call that. It's not really slope, but I guess it's how steep they are, how quick they, how sharp the curve is, something like that. Okay, so we'll just say curves are different. Okay. So, one more thing we want to just quickly examine here. Look what, here the A value is 1, here it's 2, here it's 5. How does this change my graph? Okay, so let's go and do that now. So I'm going to clear that one. Here I'm going to put log x, and then I'm going to go 2 log x, and then I'm going to go 5 log x. And I want to see how those are different. Maybe I should just change my line here as well. What should I change it to? No, I don't want that. No, I don't want that. I guess it doesn't really let me. Oh, yeah, that'll work. Okay, so let's go zoom 6. There's first graph, there's the second graph, there's the third graph. What does putting that number in front do to the graph? So you can see I've got 1. Oops. I'm going to try and keep these pretty close to the same until they cross. So I've got this. This one was log x. This one was 2 log x. This one was 5 log x. Okay, so in each case what we've done is we've multiplied the y values. This point right here, which was 1, 0, is the same because if I multiply 0, it doesn't change anything. Okay. So the same thing will happen for the natural log. It'll get, the lines will go up a little bit more. So this is just an introduction for what a log graph looks like. If we want to complete the table here, the x-intercept for all of them is the same. The y-intercept in each case is none. The end behavior is the same. It's going from quadrant 4 to 1, going from quadrant 4 to 1, from 4 to 1. The domain is 0 to infinity for each of them. And the range is negative infinity to infinity for each of them. Okay. So I'm going to stop there with the looking at all these different graphs. Okay. What I want to do is getting into some of these questions, so to show you that really there's not a lot that we need to know here. Okay. Up till now, all I want you to understand for the graph of log is that it's the inverse of exponential function. Okay, and generally you kind of have an idea of what the shape is going to be. The good news is you always have your calculator, so when it says predict, I can actually use a calculator and put it there and figure it out. Okay, so but before I do that, let's take a look at this. This is a log graph. Don't forget, this is a base 10. Okay, it's not written there, but I don't need to, it's always going to be 10. It says predict the x-intercept, predict the number of y-intercepts, the end behavior, the domain, and the range. Can you predict that? Well, I know this graph is going to look like this. Okay, I know this is going to be a 1. Alright, so I could tell you that the x-intercept will be 1. I could tell you that the y-intercept will be none. Okay, this line goes closer and closer to the y-axis. I can tell you it's going to move from quadrant 4 to quadrant 1. I can tell you that the domain is from 0 to infinity and the range is from negative infinity to infinity. Okay, and if I wasn't sure about that, let's go and put it in here and see how you would do this if this was a test and you drew a blank. Okay, so I'm going to go 15 log x and graph it. Okay, there it is. Let's say I needed to find the x-intercept. Second trace, the x-intercept, another word for that is 0. So I want to figure out what is the x-intercept, so I need a left bound. Where am I right now? X is negative. Can it be negative? By the way, this might be worth looking at. Right now it's saying the x value is negative 0.85, and you can see that says there's no y value. So let's move to the right and see when do we actually get a y value. Okay, when x is 0, still no y value. This tells me there is no y-intercept. Okay, and the second I move a little bit further, now I have a y value. Okay, so there's my flashing cursor. Let's press enter, and let's move it across the x-axis now. There we go. Press enter. So now if I press enter again, it tells me that the x-intercept is 1. Okay, so very briefly, when the cursor was over here, it was giving us no y value. The graph doesn't exist. When we moved the cursor to the x is 0 right here, it still said y is blank. That's because there is no y-intercept. Okay, then we found that the x-intercept is 1. Okay, let's try another question. Predict the x-intercept, the number of y-intercepts, the end behavior, domain and range. Again, y equals negative 4 natural log of x. Okay, I'm already predicting, I know what this graph's going to look like. This is going to be 1. And I'm going, okay, let's write all this stuff down. X-intercept is going to be 1. Y-intercept is going to be none. And then end behavior, I'm going to leave that blank for a second because I think we're going to find something strange out. The domain is from not negative infinity. It's from 0 to infinity. And the range is from negative infinity to infinity. Okay, let's graph this one because we haven't seen this negative in front before. Okay, so let's clear that. We'll go negative 4. By the way, look which negative I used. I used the one down here, not to subtract. Negative 4 ln x graph. Ooh, look at that. It's backwards. So the graph does not look like that. It looks like this. Now maybe you're thinking, oh, now I don't know what the x-intercept is. Better go find that out. So we'll go second calc. And we want to do the 0. Okay, the left bound right now, it says x is 0 and y is nothing. Okay, so we don't want to go quite there. Let's move it into the graph. So enter. And now when there, we cross the x-axis. Enter. Enter. And what do you know? The x-intercept is still 1. But what is the end behavior? We're going from quadrant 1 to quadrant 2. Quadrant 4. Okay, I like to think of that as decreasing. That's a decreasing graph going from quadrant 1 to quadrant 2. Alright. Now let's do a couple of quick matching. So how would you do this? How would you know which is which? Well, you should recognize, I'm going to do a couple of quick sketches. You should recognize this is an exponential graph. This is an exponential graph. And then you should recognize this is a log graph. And this is a log graph. So there's a couple of things we can rule out here. Alright, I can see exponential graph, exponential graph. This is an exponential graph and so is this. I just have to match up which one is which. Okay, so looking at the difference here, what is the difference? Well, it's the size of the base. The base here is 2 and the base here is 0.1. When the base is greater than 1, I know I have this graph. So this one is I. When I see that the base is between 0 and 1. I have the graph that's falling. Okay, so that's that one. Now we have two log graphs. Which one of these is 3? Which one is this? What do you think? Hopefully it makes sense that it's going to be this one because it's that general shape. What does the negative do? It makes it switch directions like that. Okay. So you have some homework to try here. Okay, key ideas, you can look through that. Go through some of these questions. I don't want you to spend too much time on logs. I'm not going to have very many questions on the test on logs. I think this course, the purpose for this is just for you to be introduced to it. It's very hard to ask questions that are fairly done, that really are log questions. A lot of these questions are forced and they don't really fit your understanding of it. So basically what we've done for examples, a little bit of matching like this, and maybe just a couple of quick equations where you have to do a sketch with some of the characteristics. That's about all you're going to have to do. So when you're doing this homework, that's all you should be really focusing on. Like I like this matching question. Okay, these ones are also matching. Okay, then you get to this word problem. I'm not going to worry about ones like this. Okay, so let's do that homework. We'll spend some time talking about questions in class, and then we have one more lesson. Okay?